In this lesson, you are going to learn how to predict products of a double replacement reaction. A double replacement reaction has the basic formula of a compound AB reacting with compound CD. What happens is there is a switcheroo, a double switcheroo. Now, these are going to be ionic compounds, which means A is a cation and B is an anion. C is a cation and D is an anion. But there's going to be an opportunity for these ions to mix it up, because these are usually done in an aqueous solution. And the cation and the anions will switch partners. So what happens is A will now combine with D, and C will now combine with B. So you can recognize a double replacement reaction when you have two ionic compounds where the cations and the anions switch places and you end up with two different compounds. So we're going to start this by predicting products of the names of the two reactants. So we have names of the reactants. We are going to predict the names of the products. So we have aluminum iodide, right? The aluminum is your positive ion, your iodide is your negative ion. Lead nitrate, the lead is the positive ion and the nitrate is the negative ion. So what are the new combinations of ions that will form the products? Well, you're going to have aluminum now hanging out with nitrate. And you're going to have lead 2 hanging out with iodide. And that's it. All right, that's it. It doesn't matter if you write aluminum nitrate before the lead 2 iodide, or you could put the lead 2 iodide first. That doesn't matter. What you do need to do is make sure that if the ion was positive, the positive ion is always written first. Right? And so you want to make sure that you keep the cation written first in the name on the product side. All right, so silver and nitrate reacting with potassium phosphate. So we're going to start over here. Silver is now going to hang out with phosphate. So that's one of our new compounds. The other compound is going to be potassium nitrate. Our third example here, copper 2 bromide, is going to react with aluminum chloride. So I'm going to have copper 2 is now going to hang out with chloride, and aluminum and bromide are going to be combined. So aluminum bromide. All right. Just going on a few more examples, but it's more of the same. Barium will combine with sulfate, and sodium will combine with chloride. Lithium carbonate and cobalt 2 chloride will become lithium chloride and cobalt 2 carbonate. Okay, so predicting the names of the products is very straightforward. You really are literally just mixing them up, making sure to keep the cation written first. It can get a little more complex when you are doing this with chemical equations. So we're going to break it down. We've got two things we're going to do here. We're going to predict the products of the following reactions by writing their correct chemical formulas after the arrow. And then and only then, once we have both compound formulas written, we are then going to balance the equations by putting coefficients in. Okay? So here's what I'm going to recommend you do if this is not something that comes easy, or this is the approach I'm going to show you. So name it, right? This is sodium, this is hydroxide. So I have sodium hydroxide reacting with calcium bromide. Okay. Now, from that, you can predict what your products are going to be. You're going to get sodium bromide and calcium hydroxide. Okay. So once you know what your names are, now you can build the formulas. Sodium is Na plus 1. Bromide is Br minus 1. So our formula here is going to be just NaBr. Calcium hydroxide. Calcium is Ca plus 2. Hydroxide from reference table E is OH minus 1. The formula for this set of ions is going to be CaOH in parentheses 2. Okay. So what I now have are our two products, and now we need to go through and balance the equation. Right, so I have one sodium. So that's good. I have one hydroxide, one OH ion, but over here I have two of them. So what I'm going to do, because I have two hydroxides, I'm going to treat that as a group. So I'm going to need two of these, and I can't change the formula because that's already set in stone. So I'm going to have to put a 2 in front of the NaOH to get those two hydroxides to match. Now, of course, we recognize that that disrupted the balance of the sodium, but I can fix that easily by putting a 2 in front of the NaBr. And let's take a look. We still have to check out calcium and bromine. Calcium, there's one here, and there's one over here. So we're good for the calcium. Bromine, we've got 2 on the left and 2 on the right. So this equation is now balanced. All right, let's take a look at our next reaction. We have silver nitrate, and we have iron chromate. And what we're going to do here is, because iron is one of those elements that needs to be balanced or needs to have a Roman numeral, we have to figure out which one it's going to be. Iron can either be a +2 or a +3, but in order to figure it out, I have to look and see what the chromate was. So chromate, CrO4, is a -2. Right, this right here is a -2, which means this iron had to be a +2. So I know that this is iron 2 chromate. Okay. So what am I going to get over here? I'm going to get iron 2 nitrate, and I'm going to get silver chromate. From this, I can figure out my formulas. Fe plus 2 is iron 2. Nitrate is NO3 minus 1. So this formula becomes Fe NO3 2. Silver chromate. Silver is Ag plus 1. Chromate is CrO4 minus 2. Dropping and swapping, I get Ag2 CrO4. All right, let's fill in. Put that plus sign in there to separate those. So now let's check a look at this balancing. On the left, I have one silver, but on the right, I have two silvers. So I'm going to fix that by putting a 2 in front of the AgNO3. Now, that gives me, I'm going to consider this nitrate, I'm going to balance that as a single thing, as a single item. So that gives me 2 of these nitrates. But if you look on the right side, we have 2 of those nitrates. So nitrates are balanced. Next element, iron. 1 of each. Iron's good. CrO4, chromate, there's 1 chromate group, there's 1 chromate group. So this equation is now balanced. Take a look at example number 3. Example number 3, we have silver nitrate again, reacting with potassium sulfide. That's going to give us silver sulfide and potassium nitrate. Right? So once I know I have silver sulfide, I need to find my ions. Silver is Ag plus 1. Sulfide is S minus 2. The formula for silver sulfide is Ag2S. Potassium nitrate. Potassium is K plus 1. Nitrate is NO3 minus 1. So potassium nitrate is KNO3. Balancing this equation. 1 silver, 2 silvers. We're going to balance that by putting a 2 in front of the AgNO3. That's going to give me 2 nitrate groups. I have only 1 nitrate group over here, so I'm going to have to put a 2 in front of the KNO3. That gives me 2 potassiums, but look, I had 2 potassiums to begin with, so that works. And then 1 sulfur, 1 sulfur. So this equation is now balanced. All right, let's take a look at equation number 4. What we have here is ammonium phosphate. And I have here lithium hydroxide. What's that? That's going to make ammonium hydroxide plus lithium phosphate. Setting up my ions so I know what the formulas are. NH4 plus 1 is ammonium. Hydroxide is OH minus 1. So this formula is NH4OH. Lithium phosphate is Li plus 1, and phosphate is PO4 minus 3. This formula is Li3PO4. Now let's balance. We're going to treat these ions as ions and not as their individual atoms. I've got 3 ammonium groups here, but only 1 ammonium group over here. So I'm going to put a 3 in front of that to give me 3 ammoniums to match up with those 3 ammoniums. I have 1 phosphate group, 1 phosphate group, 1 lithium, 3 lithiums. I'm going to put a 3 in front of the LiOH. That'll make my lithiums work. That's going to give me 3 hydroxides, but I have 3 hydroxides over here. So this equation is now balanced. Last example here, I have calcium chloride and sodium carbonate. What it's going to make is calcium carbonate plus sodium chloride. To find those formulas, calcium is Ca plus 2, carbonate is CO3 minus 2. This formula is CaCO3. Sodium chloride, Na plus 1, Cl minus 1, that's just NaCl. Balancing this equation, 1 calcium, 1 calcium. 2 chlorines, 1 chlorine. So I'm going to put a 2 in front of the NaCl to balance my chlorines. That's going to give me 2 sodiums, 2 sodiums. Sodiums are good. I have 1 carbonate group, I have 1 carbonate group. This equation is now balanced. So in this video lesson, we've done, this is sort of a summative of all the things we've worked on so far in this unit. We are working on double replacement reactions, which can be recognized by this basic pattern. Highly recommended that you know how to swap names and predict the names of the products. Once you can predict names, then that is a fairly easy jump to be able to write the formulas of the products. Once you have the formulas written correctly, then and only then can you go and balance the equation. All right, that's it for this topic, and I will see you back in the classroom.